anterior pituitary and the hormones that it has. So the anterior pituitary is different than the pituitary. Remember, the posterior pituitary was the neurosecretory part, but in the anterior pituitary, it makes and secretes its own hormones, okay? But it's controlled by the hypothalamus as well. But the way it's controlled is that the hypothalamus produces hormones that are called releasing hormones or inhibitory hormones. And these releasing and inhibitory hormones will travel in the blood and then arrive in the anterior pituitary. And if they are releasing hormones, then they will stimulate the anterior pituitary to release hormones. And if they are inhibitory hormones, then they will inhibit the anterior pituitary from releasing hormones. And this happens because we have this thing called a hypothalamic hypophyseal portal system. So a portal system, in other words, between the anterior pituitary and the hypothalamus. So what a portal system is when blood travels directly from one organ, blood vessels, to another organ, in this case, directly from the hypothalamus to the anterior pituitary. Because normally what happens is when blood leaves your heart, you have arterial blood that's going to go to an organ so that you've got oxygenated blood with lots of nutrients going to that organ. And then you're going to have venous blood carrying waste products that leave that organ. And then that goes back to the heart. But in this case, we're having blood leaving the hypothalamus and not being carried to the heart with those hormones, which would then have to travel all the way back up to the brain to get to the anterior pituitary. Instead, it's just traveling the length of the stalk of the pituitary gland to get down to the anterior pituitary. So it's taking a shortcut. And the hormones that the anterior pituitary gland secrete can be remembered by the acronym FLAT PIG, where the F stands for follicle stimulating hormone, the L stands for luteinizing hormone, the A stands for adrenocorticotropic hormone, the T stands for thyroid stimulating hormone, the P stands for prolactin, and the G stands for growth hormone. And the I, you get to ignore. So yes, I wrote abbreviations for each of these hormones, but you have to know their names. You can't just learn the abbreviations for the hormones. So let's talk about these flat pig hormones. Well, 3 of them are hormones of the reproductive system, which we'll do in much bigger detail when we do the reproductive system, but let me talk about them now. Prolactin is the gland that produces milk. Remember when I was talking about oxytocin, it was the milk letdown of milk that had already been made? Well, prolactin is the hormone that has the milk glands develop and make the milk. Then follicle stimulating hormone and luteinizing hormone each have specific things that they do, but together we can say that they're going to stimulate the gonads to make the gametes. So think of the sperm and what for now you can call them eggs, as well as our sex hormones. We'll go in more detail later on. Okay, growth hormone. So remember, anterior pituitary is under the stimulation for the hypothalamus. So in order for growth hormone to be released from the anterior pituitary, the hypothalamus has to release what's called growth hormone releasing hormone. Okay. Then the anterior pituitary will release growth hormone. And growth hormone basically has like 4 target organs. The net result is it's going to promote skeletal and muscle growth. And the way it does this is it stimulates amino acids to enter the cells of muscles and bones for protein synthesis. It also in the liver promotes the breakdown of glycogen to release glucose in the bloodstream for energy so that you can make proteins. And it also is going to promote the catabolism of fat. So you end up with a leaner, more muscular body. And as we know, growth hormone levels are highest in childhood and adolescence. And then they taper off in adulthood and it becomes really low in your 40s, 50s, 60s, 70s, and 80s, which has led to a whole industry of illegal usage of growth hormone. Now, dwarfism. There's a couple of different types of dwarfism. Pituitary dwarfism means that in childhood, you did not have enough growth hormones. So you end up with adults who have perfect proportions. They're just small in stature. So they're 2 feet, 2.5 feet tall. And so here is a lovely lady, and you can see that her arm can rest on the seat of a chair. And here is a short little gentleman, and he is less, he comes up to about mid-thigh area. Okay, and yes, these are from the early 1900s. Here is a more recent pituitary dwarf sitting on a late night talk show host. See, and you can see his size compared to the size of the hand of the late night talk show host. Now, please realize that these types of dwarfs, little people, are not the same type as in The Wizard of Oz or in other TV shows. These are achondroplastic dwarfism. This is a genetic disorder, okay? Pituitary dwarfism has to do with a lack of growth hormone in childhood. Now, if you have too much growth hormone in childhood, then the epiphyseal plate is going to make too much cartilage, which will then make more bone, and you will have long bone growth. And the person will become a giant. And that's the disease, not called giantism, but called gigantism. And so here are examples of a gentleman and a lady who are giants. And whereas it could be useful for playing basketball, you wouldn't want to be sitting in an airplane or in an automobile if you were a giant. And nowadays, this would be picked up earlier. You would notice a rapid growth in childhood. Here's an example of a gentleman who was actually considered short for his age until he was around 14 when he had rapid growth. He ended up growing 8'5". Now, personally, I think the ability to be able to sit down to change a light bulb is fantastic. But trying to find size 26 shoes because my feet were 1.5 feet long would be a definite detriment. So I will take not being a giant. And I want you to realize that the #1 cause for gigantism, as well as the #1 cause of overproduction of any of the flat pig hormones, is going to be a pituitary hormone. And you can see that this pituitary gland is about 4 or 5 times the size that it normally would be. Now, what would happen if you had too much growth hormone, but it was after you were done growing, so you no longer had an epiphyseal plate, and instead you had an epiphyseal line? Well, you wouldn't be able to have long bone growth. So the only way you'd have bony growth would be like the width would grow, right? So if your femur grew longer, you wouldn't really notice it because you've got a lot of muscles and adiposity. You know, you're not really going to notice that your thigh is a 1/4 inch thicker than it would have been before. So where you're going to notice it is where you have bones closer to the surface. So think your hands, your feet, and your face would be where you really notice it. And this is a different disease, not called gigantism. This disease is called acromegaly, which basically means big things in the periphery. And so you can compare a normal size hand on the left with the, look at the width of the hands of the person on the right. Notice the hand length is not super, super long. It's the width that is much differently. And the same thing with the feet in the bottom picture. The width is about 1.5 or twice the normal width. Now, when looking at the face, what's really common is an enlarged nose, a very prominent chin, and notice this extra bony prominence here above the eyebrow where the frontal bone would be. This next set of pictures is the same lady taken over just a 10-year period. And so you can see her nose changing shape, her chin becoming more prominent, and look at the soft tissues in her lip. Okay, there weren't any lip injections back in those days. Okay. And I gotta say, she looks like she aged a lot more than 10 years in 10 years. And so this is a classic example of somebody with too much growth hormone that happened as an adult. Okay, another hormone, the T of flat pig, thyroid hormone. And in fact, we have two thyroid hormones, and they're called T3 and T4. So as you remember, hopefully your thyroid gland here is in your neck. And your thyroid gland, when you look at it under a microscope, has these, what we call follicles, these little pink lakes of stuff called colloids surrounded by these cells on the outside. Follicle cells are follicular cells, and these cells make a protein to which the thyroid hormones attach. And so the way the thyroid hormones are made is that iodine goes into these cells and it attaches to an amino acid. Tyrosine, don't need to know the name of the amino acid. But if 3 iodine molecules attach to it, it makes the hormone T3. And if 4 attaches to it, it makes the hormone T4. And then that is stored here in the middle. And then if your body needs thyroid hormone, that stored hormone then goes back into the follicular cells, which then secreted into the bloodstream. Okay. Now, thyroid hormones don't have any one specific target organ. It has receptor cells on pretty much all the cells in your body and causes them to undergo metabolism at a faster rate, meaning you're going to have generally an increase in protein synthesis. You're going to be breaking down more glucose molecules. You're going to be using more energy. You're going to be making more body heat. Your GI tract is going to be going faster. So you'll be losing weight. You're going to be sweating more. You're going to be secreting more oil from your face. Your hair is going to be growing faster. Your heart rate is going to be faster. Your blood pressure is going to be faster. You're going to be myelinating your axons more. And because of this, thyroid hormone is crucial for brain development when you were being formed in your mother's uterus. Now, the thyroid hormone pathway is different than any pathway we've looked at before. Because remember, the hypothalamus is going to be involved. It is going to be releasing thyrotropin releasing hormone, which is then going to act on the anterior pituitary gland, which is going to be releasing thyroid stimulating hormone, which then is acting on the thyroid gland, which is releasing thyroid hormone, which then acts on target tissue. So this is a 3-hormone chain. And because it's a 3-hormone chain where the 3rd hormone is coming out of the thyroid gland, that means there's going to be 2 places for negative feedback. Negative feedback is going to go both to the anterior pituitary gland for thyroid stimulating hormone, as well as to the hypothalamus for that thyrotropin releasing hormone. But do you remember how I said we needed iodine to make T3 and T4? Well, what happens if you don't have iodine? Well, your body figures out, okay, we don't have iodine, we can't make T3 and T4. So we can't have negative feedback. So then your body says, okay, so we need to have more. The hypothalamus is going to kick out more thyrotropin releasing hormone, and the pituitary gland is going to kick out more thyroid stimulating hormone. So what's the thyroid gland going to do? It is going to start making more and more of that protein, thyroglobulin, that the iodine was going to be attaching to. Okay. Because it didn't know that there wasn't any iodine. It knows that the problem is there isn't any T3 and T4. So the thyroid gland's in overdrive. So the thyroid gland is going to enlarge. And when the thyroid gland enlarges, it forms what we call a goiter. And so here's the picture of a goiter. So anytime you see someone like, with an enlargement there in their neck, that enlarged thyroid gland, that's a goiter. Okay. So they could be hypothyroid. Okay. So their metabolism would be lower, their hair growth would be low, they could be gaining weight, their heart rate could be low, their blood pressure could be low, they could be tired all the time. But in the United States, we have been using iodine salt since the World Wars, and at least since the 1950s, it's been widespread. We had this whole part of the Midwest that it literally took until the 1950s to have iodine salt. And that has prevented this problem here in the United States. But it has not prevented it worldwide, because there are still 2 billion people worldwide that have some degree of iodine deficiency. So we can still see goiters worldwide, which are easy to treat from iodine deficiency. Now, there are other causes of goiters besides iodine deficiency, but this used to be the #1 cause. Okay. So let's go back and practice this. And I put the little hints on the dotted lines for you to fill out and to remind you, because this is a 3-hormone chain, it has 2 areas of negative feedback. And I put a little picture here that it's showing you hormones in green and hormones in red for the 2 different locations, which I gave you little hints in green and red. So work through this, and if you have any difficulty, write to me through the Canvas inbox, please. And thank you so much for all your hard work on the anterior pituitary and the flat pig hormones. And I will see you with our 4th and final video, where we talk about a whole bunch of other hormones. Thank you.